Hi, my name is Mel, and the following presentation will offer an in-depth exploration of computer monitors. We'll cover their history, technology, classifications, performance aspects, connectivity, touchscreen innovations, specialized types, selection tips, and future trends in monitor technology. So we will begin with an introduction to computer monitors, examine their working principles and review display technologies. Then we will cover advanced technologies, physical characteristics, connectivity options, touchscreen monitors, specialized types, selection criteria and future innovations. The following section introduces computer monitors by defining the purpose, tracing the historical development and understanding the critical role they play in computer systems. Computer monitors are output devices that visually display information processed by computer. Their primary purpose is to provide users with a clear graphical interface to interact with software and data. I used to, when I was back a computer technician, I used to have to repair vacuum tube monitors, and that was a nightmare. Monitors evolved from early cathode ray tubes, or CRT, displays used in the mid-20th century to modern flat panel displays like LCD or LED, which is liquid crystal display and light emitting diode. This evolution has significantly improved display quantity and quality, size and energy efficiency. Although if they break, they can be a nightmare to fix. Often you just have to end up replacing them, quite honestly. They're not usually worth fixing, but it's depending on what type it is. Monitors serve as the main visual interface between the user and the computer, displaying text, images, videos, and graphical user interfaces essential for user interaction and productivity. So it's called a GUI sometimes, but yeah, it's just that's what sometimes monitors aren't called a GUI, graphical user interfaces. Like Windows is a graphical user interface. Linux doesn't have one so much. It does have some, but yeah. We'll explore how monitors receive signals and external and key internal components and important parameters like resolution, refresh rate, and color reproduction that affect display performance. Monitors receive video signals from computers through various cables and convert these signals into images by activating pixels in a specific patterns to render graphics and text on the screen. Important components include the display panel, controller boards, power supply, and backlighting system. Each part plays a role in processing image data and producing visible output. Resolution dictates image sharpness by defining pixel count. So the more pixels you got, usually better resolution. Okay, so if you want to increase resolution, you need like often a monitor or something, a TV, anything that has got a better pixel count. Refresh rates affect how smoothly images updates, important for motion clarity. Color reproduction determines how accurately colors appear on the screen. The section reviews major display technologies including CRTs, LCDs and LED monitors, discussing the working principles, features and benefits. Not many CRTs used now, LCD some, but LEDs get really more used now. CRT uses, or cathode ray tube uses, electron beams scanning phosphor-coated screens to create images. Known for deep black colours and colour accuracy, but are bulky and power-hungry compared to modern displays. They certainly are, and a lot of things can go wrong with them, quite honestly. LCDs use liquid crystals and backlighting to produce images. They offer slimmer profiles, lower power consumptions, and less flicker than CRTs. They became the industry standard. And look, LED is sort of used a bit more now, I think, but LCD is still around. LEDs are essentials LCDs with LED backlighting, offering better brightness, contrast, and energy efficiency. They enhance colour range and enable thinner panels. Yeah, so LEDs are used way more now, honestly. But repairing any of these is, I wouldn't. I would like take it somewhere and they can strip it for parts or something. You know, like if it breaks down, just get a new one. I'm not worth repairing. It costs you more than a new monitor, seriously. Explore newer technologies like plasma, OLED, panel types, and specialized monitor shapes that improve viewing experience and performance. Plasma monitors used ionized gases to produce images offering rich colors but are less common now. Yep. OLEDs use organic compound emitting light, delivering superior contrast, color accuracy, and flexibility. Yeah, plasma's hardly used anymore. I would not think plasma. OLEDs are probably around, yeah, I'd say. IPS panels provide wide viewing angles and accurate colors. TN panels have faster response times but narrower angles. VA panels offer high contrast with moderate viewing angles suited for various uses. Curved monitors improve immersion and reduce distortion, especially in ultra-wide screens. Ultra-wide monitors offer expanded workspace and enhanced gaming or productivity experiences. Yeah, like so you can use ultra-wide monitors and much larger computer monitors or TVs for like gaming and like good workspace. So I mean that's something people can choose to do. I think they're expensive though, but they can be very good, especially for gaming or productivity. If you're doing high volume, then you would need those. We will discuss essential physical traits like screen size, aspect ratio, and pixel density, along with performance metrics such as brightness and response times. Screen sizes range widely to suit user needs. And look, the smaller it is, the less you get, the less good it's going to be. The bigger it is usually the better. But also you got to think of like, pixel ratio and all that sort of stuff. Aspect ratio just determines screen shape and usability, with common types being 16:9 and 21:9. Pixel density influences image sharpness and clarity. So yeah, that's like 16:9 is common, but so is 21:9. So if you're looking for a computer monitor or TV, look at those. Pixel density much, so I'd pick if you can afford it, pick a bigger screen with aspect ratio that's better and a pixel density that's better too, all right? Brightness affects screen visibility in different lighting conditions. Contrast ratio defines difference between dark and light areas. Viewing angles determine how colours and brightness shift when viewed from the side. Response time measures how quickly pixels change colour, important for motion clarity. Input lag is a delay between a user action and its display, crucial for gaming and real-time applications. Yeah, so if you're going to have like gaming on applications that need like good, like a good response time, that was something you're looking up the more high end of monitors and TVs there, because you can use TVs as computer monitors. There's no reason why not. Pretty much same thing goes. They just take input, like a smart TV, smart monitor, whatever you want to do with it. This section covers various connection types used to link monitors with computers and other devices, including multi-monitor setups and daisy chaining. VGA is an older analog standard providing video signal transmission and not often used now. DVI supports both analog and digital, but is largely replaced by newer digital connections. Yeah, look, newer digital ones are used way more than VGA or DVI. You won't see many monitors and TVs with those now, okay? HDMI, which is common, and DisplayPort are common digital video interfaces supporting high resolution and refresh rates. USB-C combines power, video, and data in one cable, enabling versatile connectivity. Yeah, all of those are really important. You know, like DisplayPort's very good, so is HDMI. You get a lot of sound and stuff out of that as well, so something to consider anyway. Multi-monitor configurations enhance workspace productivity. Daisy chaining allows connecting multiple monitors in series via DisplayPort, reducing cable clutter and simplifying setup. We explore how touchscreens work, their advantages and limitations, and their common applications in various sectors. Resistive touchscreens respond to pressure and work with any input device. Capacitive screens detect electrical properties of the finger, allowing multi-touch and better clarity, but require conductive touch. Touchscreens offer intuitive, like basic control and versatility. However, they may reduce screen clarity, incur high costs, they certainly do, and are prone to fingerprints and accidental touches, yes they are, and can be difficult to use sometimes for some people. Some people do very well with them, other people don't, okay? Touchscreens are widely used in kiosks, interactive learning, point-of-sale systems, and gaming, enhancing user engagement and operational efficiency. And look, if you've got a touchscreen, there's no reason why you can't also use a keyboard and a mouse, because most computers, you can use all of those, right? So you're not just limited to a touchscreen. This section covers monitors designed for specific needs such as gaming, professional work, and portability. Problem is, touchscreens do break a fair bit and can be expensive to repair and replace, so just remember that. Gaming monitors often have high refresh rates, low response times, and adaptive sync technologies to provide smooth, responsive gameplay experiences. So yeah, you can get specifically monitors specifically made for gaming. They are quite expensive though, but look, they can be very, very good if you're gaming a lot or writing games or testing games. They can be very good, but they are expensive. These monitors emphasize color accuracy, wide color gamut, and calibration capacities and capabilities essential for creative professionals requiring precise image reproduction. So that'd be like graphic design and video editing if you're using these types of monitors, okay? Portable monitors offer convenience for mobile work, while rugged monitors are built to withstand harsh environments, making them suitable for industrial and outdoor use. And a lot of people use like rugged monitors and computer systems if they're going outdoors, like, you know, out in the field, because they require, you know, things that are not going to break down every 2 seconds. That's probably a good idea. We will review key considerations to help users choose the best monitors based on use case, budget specifications, and ergonomic factors. Consider the primary use, gaming, professional work, general use, and budget constraints to find monitor matching performance needs and affordability. And yes, look, general use, you can normally get by with general use monitors. They're a lot cheaper to get. Professional ones or gaming ones tend to be a bit more expensive, so you're going to have to think about that. But you might need them if you need high performance, all right? But just obviously budget and cost is going to come into this a great deal. Evaluating technical specs alongside user experiences help identify monitors that deliver reliable performance and meet expectations. Yep. So look, you can look at technical specs and like what, you know, user comments when you're buying monitors. And look, you might want to go to a specialty computer store where people actually know what they're talking about. to get like gaming, high-end computing or high-end computers as well, because like, you know, the average, you know, Officeworks or the average Dick Smiths or whoever probably aren't going to be, you know, have all that much knowledge. So it's just something. JB Hi-Fi, again, you know, look, they've got some good stuff, but if you want really high end, you're looking at different sort of companies. All right. Adjustable stands, blue light filters, flicker-free technology, and anti-glare screens help reduce eye strain and improve comfort during long usage. Yeah, and that is something you can get. Like, I get like anti-glare screens and, you know, stuff that's better for your eyes too, because that would be, you know, that's something you've got to look at as well. The final section explores emerging display technologies, sustainability efforts, and anticipated user experience advancements shaping the future of monitors. Technologies like micro LED, flexible displays, and high-resolution panels promise improved brightness, efficiency, and versatility in future monitors. Yep, and like they're bringing down the cost of a lot of this stuff as well, so that's something you can look to. Manufacturers are focusing on eco-friendly materials and reduced power consumption and recycling programs to minimise environmental impact. Yeah, and we need to push this, like all manufacturers of all electronics, have like electronic waste bins in like every city or something, so people can dump, you know, electronics that no longer work, so they can strip them for parts or whatever, recycle them, you know, recycle things as well, you know, like the copper off the boards or anything like that. So, you know, like less goes into the dump. We anticipate more immersive, interactive, and personalised display experiences, including integration with augmented reality and AI enhancements. Yeah, that will definitely is coming already. All right, there's stuff already here. It's just becoming more used slowly. Computer monitors have evolved dramatically, offering diverse technologies tailored for different needs. Understanding their features, technologies, and trends empowers users to select the best monitor for their requirements. Yep. Okay, so that is sort of a very brief overview of computer monitors. Obviously, there's a lot more to it, but this is it for this video. Thank you for your time.